everybody, the First Principles Podcast. Today is the episode on electric vehicles and the environmental waste that is associated with them. Of course, we know that environmental concerns are not really something that we talk about when it comes to our electric vehicles. When we think of a Tesla, we just think of like, oh, it's so awesome. Like, I'm doing such a good job for the environment. I'm driving this thing 0 to 60 in like 1.9 seconds or whatever it is. But the sad reality is that there's a cost to everything in life. And we're here to take a quick look at that and try to see what that is. Try to take a look at things that maybe you haven't considered before. And what are your thoughts on that, Elliot?
Yeah, with the recent announcements on the use of EVs in many countries, and they're growing, that market growing, the idea that there's going to be a large number of electric vehicles on the road in the near future is, it's going to happen, right? Mm-hmm. And the idea behind the electric vehicle is that it's a solution in a way, a solution to the combustion engine, a solution of getting fossil fuel driven cars off the road, and it is that. But it comes with some environmental impacts, and we need to look at what those are and make sure that this solution is a solution and not just trading one problem for another.
I think that's really important, because it's easy to like just go chasing after the next like shiny object. There's like that shiny object syndrome. So we have a tendency to go like, oh, this is like the next best thing, or this is the next best thing. And maybe there is. Obviously, there's a huge potential to electric vehicles. And I think one of it is something that I've talked about before. It's what comes down to when we have electric vehicles, you're kind of decentralizing you're centralizing the emissions. So when you look at the combustion vehicles, there's tailpipe emissions, and that's decentralized throughout the city, right? So you have it throughout the streets, throughout the highways, and there's various models that track how these emissions spread throughout the city. Now, when it comes to a city, town, municipality, whatever, that is more predominantly the drivers, the fleet of vehicles are electric vehicles, then now we're removing those tailpipe emissions and centralizing it towards the power plant from which the electricity is created. But then, of course, the question is, what is that power plant, and how are you getting that energy? And of course, with increased use of electric vehicles, there could potentially be more of a demand of energy. So where is that energy going to come from is one question that we need to consider.
Absolutely. Yeah, and not just the power plants, but the mine is another centralized point of emissions that will start to grow as the electric fleet grows, because with more electric cars, you need more of the raw materials mined, and the mines are another source of emissions, whether it's CO2 or other. And the important thing to always consider is the different ways that we measure environmental impact. There's a high focus right now on CO2 equivalent, CO2 emissions, because of the role CO2 has in global warming. But there's also environmental impacts in terms of wastewater produced at mines, and other types of emissions, non-CO2 emissions. So let's look at the scenario here. EVs are removing emissions in cities. There's no longer the tailpipe CO2 emissions are no longer the particulate. There's no longer the other emissions associated with combustion engines. But these emissions have moved other places. Now, we're not here to talk too much about where those emissions are and how they can be captured or anything like that. But that is a reality that has to be considered when you're looking at the environmental impact of these vehicles. Today, what we want to focus on is the materials that are unique to EVs and their environmental impact. So we're talking rare earth metals, we're talking lithium, and what is the environmental impact of extracting those metals. And when you really sum this all up, is it that much better than a diesel or gas car? I mean, the obvious answer is yes, it must be. That's why we're doing it. Right.
Sometimes obvious isn't so obvious, though.
And that's what we want to get into.
Because the thing is that there have been environmental regulations that have led to combustion vehicles to decrease their tailpipe emissions, right? And it's, if you compare the modern, like 2021 Honda Civic or whatever to like your 1970s vehicle, and the tailpipe emissions, it's like uncomparable. So there's been progress for the combustion engine, and I don't think it's gonna go down without a fight. I think there's a lot of automakers that will put it up, but I don't know. It's there does seem to be like a lot of market shift where some companies are even saying like outright that they're gonna switch exclusively to electric vehicles, right? What is it? Volvo, I think, is one of them. Correct me if I'm wrong. But yeah, I do believe there are a handful of them that are going to go exclusively that way. So it's going to be interesting to see how which I think is good ultimately, because it's going to further put pressure on combustion vehicles to become even better in terms of their environmental emissions. And because if the market is looking for more environmentally friendly vehicles, then like that's kind of like what they have to provide, whether it's like a combustion engine or an electric engine, an electric motor, excuse me. But I think overall it's good in that sense. But yeah, I think what are your thoughts?
Yeah, I mean, I think diversifying the way we do transportation is good, and as long as we trade
competition, right?
As long as there's competition, but we also trade in an equivalent manner. And what I mean by this is that we get rid of, if we're going to have companies say we're getting rid of a gas combustion car and replace it with an electric car, that electric car in my mind has to do exactly the same thing in different climates, in different environments, at least, if not do better. And and that's just for the performance as like a good principle for like producing products, but then when we talk about the environmental side of it, we got to make sure that when we make the EV, that equivalent product, that it still is actually beneficial in an environmental sense, because there could be a scenario where as you push these out, certain practices get cut, like in a rush to produce thousands of cars. We end up just trying to mine very quickly. We push those markets, grow in places that have low environmental regulations, and ultimately we get this technology, but it costs at what cost, right? Yeah.
Especially when you're so heavily dependent on a potential like competitor, a potential enemy such as China, right? Where like some of the rare earth metals that are required for these electric vehicles come from China, which is the number one supplier of neodymium. I love that name, neodymium.
Neodymium. Never even heard of that.
By Theodore Gray, I believe. Never mind. Yeah, neodymium. But yeah, they are the largest provider of this rare earth metal, which is used as a magnet within the electric vehicles predominantly. And the issue is that it is predominantly supplied by China. And,
right.
Now with kind of some concerns about like supply and, do you really want certain things to be coming from somewhere where they can like kind of put a bottleneck on it, which they did apparently in the 2000s, where like it shot up the price by like 700%, 2000%, something like that. So essentially you have this good, it's an input to a product, and that input is highly suspect, where it can fluctuate in terms of cost, it can fluctuate in terms of availability, because you're dependent on a potential foreign foe / ally. I don't know. It's better to look at it as an ally, but I don't know if they look at the West as an ally or a foe. But it kind of like brings the idea where like maybe there's better investments to be done for like, and that's the case for like ethical mining, right? Where I've talked about this before, and kind of like you've laughed at me, but I'm just
I don't remember laughing.
But just like when you have mining that's done in like, for example, Western countries such as Canada versus the mining that's done in China, like I can imagine that there's kind of higher standards in terms of the environmental emissions, in terms of finding in terms of even community outreach to local native indigenous communities. And then also not only that, but getting them involved in getting the local indigenous people jobs, high paying jobs that they will benefit from for themselves, their families. So there's all these things that are in place in Canada when these large multi-billion-dollar mining projects do occur, which are arguably done in a more ethical way than if you were to do it somewhere where there's less requirements in terms of the environmentals and the working conditions, the labor requirements, the requirement to include like talks with local indigenous communities, the local impacted groups, all these things. There's so many like levels to this shit.
Absolutely. Yeah. And it's difficult to say 100% what the conditions are in countries outside the ones that people know, and there are document cases, of course there are, of mines operated in horrendous ways, whether it is for environmental reasons, whether it's for the rights of the workers. This is a reality, and there's always complications now with resources that come from all around the world because of the geopolitics of things, and that's something that we have to navigate as we develop a new technology, or anybody who's developing new technology has to navigate, where are we going to source these things from, and what are the challenges related to getting these products. I think it's the case we're making here, though, specifically for environmental impact is, and then we've said this before on a previous podcast, is mining is hard on the environment. That's the reality of mining. You're extracting, some resource out of other rock, other
scarring the earth.
You're scarring the earth, and so it's not pretty. But it is. If you're going to mine, there are ways to do mining that's better than others.
Yeah.
So
and which I go back to the point where like, yeah, certain people do it better than others. So
yeah,
ethical, go Canada. Smart. If we're smart enough to actually invest in our freaking natural resources, but don't even get me started on that. You want to maybe jump into some of these clips?
Yeah, let me set this up. So I'm going to talk about lithium. Lithium is a key component to the battery, and I think understanding where lithium comes from, the life cycle of lithium, or of specifically of like the battery, is important in understanding environmental impact of electric vehicles, because lithium batteries are not just used for electric vehicles. Obviously, they're used for all sorts of electronics today, and lithium has become the choice, I would say, for high density batteries that basically provide a lot of storage in a lightweight, compact manner. So let's talk about lithium and see what from when it's mined out of the ground to its end of life, what's happening. Mm-hmm. So the first clip is from a YouTuber. His channel is called Just Have a Think, and he focuses on climate and sustainability topics. He himself, he says he's not a scientist. He's a British-born gent who basically has an interest in sustainability and the climate, and he has this little bit about lithium. I
think, like, just to touch on before we jump into the clip itself, but like what you just touched on there for looking at like the life cycle of a item, it's something that we've discussed with another episode as well, and it's something that I think is important because sometimes we get fixated on like one element of the production process, which is like the creation, extraction, but then there's also like the disposal that we have to consider, which maybe is something that gets less of public attention and less like media coverage, and that's where like the whole importance of doing the life cycle analysis, the cradle to grave analysis, really comes in, because something might look good up front, but then the downstream costs might make it not so good. So that's why it's really important to have that framework for analyzing these types of complex issues.
100%. Yeah, that's exactly right. And something like lithium batteries for EVs, in this first 10-year period of electric vehicles, they might still be around, they might be functioning correctly now, but like anything, lithium batteries for EVs eventually they die, they break down, and they need to be replaced. So that's the waste generation. What do you do? Can we extract lithium out of it and reuse it? That recycling process, that all has to be considered. It's maybe not being considered, or you haven't heard a lot about it recently because it's still very new and this waste hasn't come about yet. Like I think right now there is more demand for lithium than to create these batteries than there really is to deal with the waste at this point. But as we'll get into, dealing with the waste will become a key
it's coming up.
Yeah, a key thing that we need to focus on and think about if we want to create a sustainable product. Yeah,
totally. So let's jump into this first clip and see what's up.
The carbon footprint of an electric vehicle over its entire lifetime is far less impactful than a petrol or diesel car. That's not just the view of environmental groups and dedicated electric car makers like Tesla. Those are also the findings of none other than the mighty Volkswagen Group themselves. But the initial production of an electric vehicle currently carries a carbon footprint almost double the size of ICE cars. And the reason for that is the batteries, and a big part of the battery footprint comes from the extraction and processing of lithium.
Right. So the initial construction of an EV is, when you look at it in terms of its CO2 footprint, is double that of a diesel car. And what I want to focus on some of the wording here that he says, because he starts off by saying the carbon footprint of an electric vehicle over the entire lifespan, of its entire lifespan, is far less impactful than a petrol or diesel car. That seems obvious. That seems why we're doing this, right?
Yeah.
And then he goes on to say, it's not just like Tesla saying this, and EnviroHead saying this. This is Volkswagen did an analysis, and he actually has a graph from the Volkswagen analysis that he shows up on his YouTube channel as he's talking about this. And I took a closer look at this graph. So this graph is looking at the climate footprint of the e-Golf, their electric vehicle, versus their Golf diesel. And it's broken the vehicle into 3 phases: its production, its user phase, and then its recycling. And it tracks on this graph its CO2 equivalent footprint for each of these phases. And what you see right off the bat, you see the footprint of the e-Golf is double that of the diesel. But as you go through across time, and in this case they don't track it in years, but they track it in mileage or in kilometers, that line with the electric vehicle crosses the diesel, and the final placement is at 2,000 or 200,000, I should say, kilometers. And the CO2 footprint falls less than the diesel. Now, I'm like, okay, that tells the story. But
at what point does it cross?
Right. What point it crosses is something that I find fascinating. It crosses at 125,000 kilometers. Now, this is an interesting number because if you look at average kilometers in Canada, we have, natural, what did I find? According to the Natural Resource Canada Office of Energy Resources, the average mileage per year in Canada is around 15,200 kilometers. So if you took the 125,000 kilometers that basically to get to that crossing point and divide it by the average use per year, basically you need to drive that e-Golf for 8 years before it becomes has a CO2 footprint that's less than the diesel. Now, this is not unusual because something like a reused stainless steel or plastic water bottle the idea would be you make this product instead of using disposable single-use water bottles.
Right.
But
higher energy input. There's
always higher energy input to create this more durable product. So over time, and initially, it actually was more to build that reusable water bottle, but over time, you basically pay for itself. But I want to point out here that 8 years for vehicles is quite a long period of time. Depending on the quality of vehicles, especially diesel and gas cars, you start to run into issues for some vehicles around 10 years about how much maintenance costs for keeping this thing on the road. So the EVs will have to be made to last a good chunk of time if they are to actually, this e-Golf to actually be breaking even with its counterpart. And the other thing I would like to point out is diesel itself has a higher CO2 footprint than gasoline. So by comparing their diesel version against their CO2, against their EV, I should say, they're accentuating the difference. But if you actually to put compare it to a gas vehicle, you would actually it would even take longer for the EV to cross the CO2 footprint of it, because the CO2 footprint of gas is less than diesel. And that's according to another NRCan one that says basically,
wait, if it would take longer, then wouldn't the CO2 footprint be higher?
The CO2 footprint of a gas one is lower than the diesel.
Okay, but then if that was the case, then wouldn't it take longer to break even?
I messed up.
No, I'm just thinking because I think with diesel is that they're seen as more efficient in terms of per mileage, in terms of their CO2 emissions. But they release like other emissions like that, like more particulates and that type of stuff that you don't get with and like sulfuric, it's like SOx emissions that you don't get so much with the combustion engines. But with the combustion engines, you have higher CO2 emissions like per mile, if I'm not mistaken. So then that's why if it was higher CO2 emissions per mile, then that's why it would take even longer for it to break even with the relative to the diesel. So the diesel would actually be like underrepresenting what a gasoline would do. Or would it be
this is what I was basing it off. So gasoline engines produce 2.3 kilograms of CO2 per liter of gasoline consumed, compared to a diesel engine, which produces 2.7 kilograms of CO2. So the difference is 2.3 kilograms to 2.7. So the difference is 0.4.
Oh, so gasoline is less, 2.3?
Yes. So,
and that's theirs. Their gasoline, diesel versus their diesel versus their gasoline.
Yeah, no. So I don't think I'm wrong here. I still think if the footprint of the overall footprint of the gasoline car is less, basically it drags down. It not drags down, but it would take longer for you need to basically drive the e-Golf longer to surpass the footprint.
Yeah, well, if it's less than, so read me the numbers again. If it's 2.3 versus 2.7 for the
kilograms of CO2 per liter of gasoline consumed. Diesel engines produce 2.7 kilograms of CO2 per liter of diesel fuel consumed.
Okay, but that's
tricky because they don't.
I was thinking more like per kilometer driven. That would be like the better analysis,
right? Because the amount liters of diesel used versus the liters of gasoline used is going to be different. It's not going to be a 1-to-1 for the engine.
And if we're looking at like the distance driven for like the payback period in terms of the CO2, right? Ultimately, our basis should be relative to like the distance or the kilometers driven, right? Okay. So something to think about.
Yes, and putting that point to the side, and focusing just on what the results of this Volkswagen study shows us, having the EV cross, at 125,000 kilometers, that to me is not an immediate benefit. That again, it goes back to the point that you have to have a car. It's only after 8 years of use of the car on average that you're going to have a benefit.
Not only after 8 years, but that's more than like over 65% of the life of the vehicle. So you have to, right? Because if it's 200,000, the estimated life expectancy, and you're going to break even at 125,000, then what is that? Like you're roughly around like 70%, 60 to 70% of that life that you have to drive of that car. Yeah,
it's better, but it certainly is not the it's not a far less impactful. Like, I think when you say far less impactful, it's a bit misleading. It is less impactful, far less impactful. We can get into semantics with that, but it takes some time for this. And now, if they could get down the initial CO2 footprint, the EV would perform a lot better. So,
I just had like, oh my God, Wow. Okay. I just had the crazy thought. Okay, but okay, take this in. We just realized that it takes 8 years for the diesel vehicle to break even to the electric Golf.
Or vice versa, but yeah, exactly.
Right?
Yeah.
And then for the gasoline, it's going to probably take longer, like let's say 10 years.
Right.
So, like, when you think about this kind of push and this narrative that's being kind of promulgated in media, where it's like, oh, we need to shift towards like an electric economy by 2030, or else like where the world is gonna end or something like that, right? Like it's over. It's catastrophic. It's global extension, like execution. I don't know what the hell. People are saying.
The more extreme narratives are up there. Yeah.
Okay, but we just discovered that it takes minimum 8 years to break even, right? You see where I'm going with this?
I see where you're going with this, and so, of course,
what year are we?
2021.
And how long are we until 2022?
We're pretty close to 2022.
So we're pretty much 2022.
We're in November.
At 8 years.
Yeah.
Plus 9-10. Let's say for the gasoline. Okay, let's say 8 years. So we're pretty much at that mark.
Yeah.
Of like 2030.
Yeah.
So at 8 years, so the payback period for these vehicles.
Right.
So
yes, and this is what's interesting about this. So, obviously, this is a study done specifically of Volkswagen's e-Golf to diesel. You can't apply it to everything. But if we were to simplify this and say, right now, we're just going to get rid of all vehicles and use the e-Golf, and under the current conditions and assumptions that were used to make this assessment, what you said holds up. Mm-hmm. There is no reduction in CO2 for the next 8 years.
Yeah. In fact, it's yeah, I guess if it's even before that, if we're looking at like by 2030, it's more.
Yeah.
So we're actually be like, no, like if we're looking at like a 5-year like trajectory, if we had like a 5-year game plan, this wouldn't be good. Like converting to electric vehicles would not be good if we set ourselves like a 5-year plan.
Yeah. And this is why all these very quick, these short deadlines that things are going to happen, we need to execute now, are just ridiculous. Not just because, simply because some of the solutions won't even, help with them, even if they're implemented immediately. Mm-hmm. So there's problems that are created by trying to push something really quickly. And people go, oh, slow down. If we could probably do a better job. No, we got to implement it now. Well, that's going to cause problems to just implement it now. And then on top of that, the solution is not even going to do what you think it's going to do.
Exactly.
And again, we got to focus on, we're hyper focusing on the CO2 issue. And that's only one metric to look at. So I always want people to remember that CO2 is just one metric to look at when we're talking about environmental impact.
For sure. But want to jump into this second clip?
Let's listen to this guy a bit more.
Our modern utilisation of lithium carries a double whammy impact on the environment. Firstly, at the start of its journey, when it gets extracted and processed, and then again at the end of its life, when it gets disposed of. There's two main ways to obtain industrial levels of lithium today. It's either pumped up from underground brine reservoirs and extracted by a process of evaporation, or it's mined directly from rocks. Brine reservoirs are found in salars or salt flats, high in locations in hot, dry countries like Chile, Bolivia and Argentina. The mechanics of this method are pretty basic. The pumped up brine is left to sit in absolutely enormous ponds, allowing the heat of the sun to evaporate off all the water and leave behind the various mineral salts, including lithium. The brine typically has a lithium content of anything from a few hundred parts per million, or ppm, up to about 7,000 ppm, and that raw material then gets processed into lithium carbonate, which is a white powder that can be converted into other salts and chemicals, or processed again into pure lithium metal.
Right. So now he's talking about, where does lithium come from? How do we obtain it from the earth? And when we talk about mining, a lot of people think about mining lithium from hard rock, and that is one way which lithium is attained. But there's a lot of mines that use this brine method, which is basically pulling up groundwater, that salty groundwater, and laying it out in these ponds in a thin layer and letting that water evaporate, and then extracting salts that are in concentrations in parts per million after that water evaporates. And right, this takes up land. This uses water in a certain way. Salt water is hard to use in other ways, so there could be an argument made that its use is limited. But this does take up large chunks of land and has a CO2 footprint. Currently, most of the mines that are actually producing the vast majority of lithium are outside of Canada and the U.S. They're in South America, they're in Chile, they're in Australia, and they're being processed out of China. So the point I just want to make here is that lithium is a finite resource, much like the finite resource that we talk about with fossil fuels. Now, key difference is when you combust fossil fuels, you're destroying it, converting it into CO2 that has impacts. Lithium is a finite resource. You're not destroying it when you use it in batteries, but you could, if you don't recycle it and extract out the materials from it at the end of its life, you are essentially making it similar to gasoline in the sense that you're tossing it away. You're treating it as waste. So lithium, we got a lot of it on the planet. Once we start to extract it, it will become essential for this to be sustainable for us to recycle. And that's kind of the point I want people to focus on, that there is, this entire process needs to be considered from where it's coming from to where it's going.
Yeah, because I think like with the combustion engine, we burn the gas and it goes into the atmosphere. So that's what we want to avoid. Okay, great. But then when we have the other option, okay, the electric vehicle, then we have an electric motor, and okay, we're not putting the emission into the atmosphere, but we still have an emission, which is ultimately the waste byproduct from this motor, which after 6-7 years, whatever, is disposed of and then maybe used for energy storage for another 3-4 years, and then afterwards is puts. So then what do you do with that? Well, now that again, that output, that externality isn't going to the air, it's going into the ground or wherever, or is it being recycled, or what is actually happening? So that is the question that needs to be considered, I think.
Yeah, exactly. And I think if you are not familiar with lithium and how it's extracted and these studies that look at CO2 footprint, you're thinking like right from the beginning, this is low CO2. But as we've already pointed out, the amount of the CO2 footprint of just extracting this stuff, like you said, is very high, and that is, I think, eye-opening. Now, I have the next clips are from CBS, and they did a recent little bit on lithium batteries and current production around the world and what's going on in the U.S. I took a few bits from this overall segment they did, and we can jump right into that clip.
Okay,
if
next
you're good.
clip coming up.
Yeah.
With automakers pledging to soon make most of their vehicles electric, lithium demand is expected to increase as much as tenfold in the next decade. Right now, most of it is mined in Chile and Australia, and almost all of it is processed in China. The United States has just one lithium-producing mine in southern Nevada, providing less than 2% of world supply.
Right. So a lot of that I've already said, but the fact that the U.S., which is one of the key players in terms, or leaders, I should say, in trying to push the EV revolution forward, trying to get gasoline cars off the road, has only one mine that's only providing 2%. Just speaks to, again, some of the ways in which we're not seeing up close what the real environmental impacts are. These things are, this is, I just want
elsewhere
are happening elsewhere again for the benefits of a richer Western country.
Yeah. Oftentimes in countries where, again, we sacrifice environmental issues or regulations or labor regulations, and that's why they're able to get away with like maybe more profits for these countries. But it's kind of like out of mind, out of sight, or out of sight, out of mind, But actually, I want to correct something that I said earlier, because I just looked this up, and there's a sheet that looked at emissions of a Volkswagen Golf TDI versus a Volkswagen Golf TSI, so the gasoline version. And apparently, in terms of the CO2 emissions, there was a bit of a higher emissions in the diesel version, so 117 grams per kilometer versus 113 grams per kilometer, so slightly higher emissions on the TDI. Next clip?
Yeah, let's jump into the next clip. So that's a continuation of this CBS segment.
Lithium is now so valuable, it's called white gold. There's believed to be billions of dollars worth of it here at Thacker Pass alone. And while it may be essential to a greener future, getting it out of the ground comes with its own environmental cost.
The claim that this would be a green mine is extremely dangerous.
Max Wilbert is part of a group of protesters
this is our camp.
Who have been camping out on the Thacker Pass mine site since January. He says lithium is not the silver bullet many believe it to be, because of the impact of mining on the land and the large amounts of wastewater created by lithium extraction. If we're trying to move away from fossil fuels, is the environmental impact at a site like this the lesser of two evils?
That's a really good question, but I think the problem is that's the wrong framing. Global warming is a huge problem, but in this attempt to save the planet from climate change, people are actually believing that we can save the planet by destroying it.
Lithium Americas admits there will be environmental impacts, but claims new mining technology will lead to less damage. The company plans to begin its operation next year, potentially creating a lithium boomtown in nearby Winnemucca, Nevada.
Winnemucca, Nevada. Yeah. So I included this clip, and to give you a bit of context, there's environmental activists camping out in this region, basically protesting this mine from being developed. And the reporter goes down there, and the question he asked them is, if we're trying to move away from fossil fuels, is the environmental impact at a site like this the lesser of two evils?
Mm-hmm. Important question.
It's an important question, and why? Why are we trying to move away from fossil fuels? I think I'm correct in saying we're moving away from fossil fuels. Primarily, the push right now is because, not that we're running out of them, but because of the CO2 issue. So we're basically, if you measure it from CO2, the reality is the CO2 benefits of lithium aren't great if not done correctly. If you can't get down the CO2 footprint of mining, and you also are still using coal fire plants to make your electricity to run these vehicles, and you're not putting any scrubbers on them, then I'm very confident, I should say, that the CO2 balance doesn't actually look that great. It's just basically a shifting of where that CO2 is being outputted. However, if you can bring down the CO2 footprint of mining and you can bring down the CO2 footprint from the electric production, then we're talking. But,
I think that's where like localized scrubbers come in though too, where like that could be like the benefit of having the localized emissions is that like it's a more controlled way of having of attempting to then sequester those emissions. And I think that's one of the benefits of having like moving away from the combustion vehicles towards like those centralized point sources, was that like it would make it easier, right? And when you have like just one source that you have to deal with when it comes to taking out all these carbon emissions, if you just come from like one place versus like all over the place, like that's spread out throughout the whole city. It kind of like helps the task. Of course, again, it's not perfect, but it kind of helps. But then again, we have to look at like an increase in energy that does need to come in order to sustain a grid that is not going to be demanding more electricity in order to sustain
a lot more
the fleet of electric vehicles. So that's also something you have to consider. So if we're requiring a higher demand, then we either might need to build more natural gas plants, or more perhaps renewable energy. But then we know that can be kind of like unsustainable in its own sense. But then that's just where like the smart grid can come in, and ultimately it could be like where we are headed to, where we have smart grids that are kind of maneuvering and optimizing like what method of energy comes from at what point in time. But
it's like very complex, and what I want to
complex
point out is that if we don't develop these technologies in parallel, then the benefits of them aren't realized until much further down the road than people think. So it's like, it's great to say we're gonna it's easier to control the emissions at a centralized point. I agree with that, but if that doesn't happen, if people aren't putting the money investing into scrubbers at these centralized plants, then lithium doesn't look so good, and you're kind of defeating the purpose, because it's going to, why are we doing this? Well, why right now, whether you agree with it or not, is because we want to overall reduce CO2, our CO2 footprint. If these things aren't done in parallel, we're not actually going to be doing it. We're just shifting things around.
Yeah, exactly. Just like a sleight of hand kind of going on.
And so when he responds, I'll read what he responds, and for whatever it's worth, he says it's a really good question, but I think the problem is it has the wrong framing. Global warming is a huge problem, but the attempt to save the planet from the climate change. But this attempt to save the planet from climate change, people are actually believing that we can save the planet by destroying it. So he to me, I take issue with this, because this is again kind of, when he says destroying it, I think he's talking about the impacts of mining. Like, he's talking about physically altering the landscape, right? I love the beautiful natural landscapes, but I also accept that mining is a reality, right? And so it's to me, he kind of could have made a better argument here if he actually brought up the concept of CO2 footprints and moving them around, and that if you do the checks and balances, things don't actually look as good if these things aren't done. But he's still focused on what mining does to the landscape. And yes, so when they say at the end of that clip, the mining company says we have modern ways to reduce our environmental impact, they're talking about probably wastewater treatment from the mine, reducing that, just studies ahead of time to make sure they're not going into habitats of endangered species, these type of things. And this all is these are all good things. These are the things that make the mining practice better. And but I just want to say that I feel like he kind of missed the point he could have made when responding to that reporter there.
Yeah, definitely. I think it comes from like maybe an unrealistic look at the world, where like you think that okay, it's like where do you think things come from? It's just like, if there's a saying where if it's not grown, it's mined, right? And when you think about it, it's like, yeah, like everything that we have, if it's not grown, is mined. If it's food, if it's clothing, if it's a table, like everything comes from the ground, or like to a certain degree. So when you're talking about like destruction, like it just comes from like this simplistic look at the world, or like, I don't know, this look at the world where it's like everything is rainbows and sunshine and unicorns and daisies, and just like, yeah, like it's welcome to reality. Like, this is how things work. We, like, how do you think you got that iPhone or that smartphone in your pocket that lets you communicate with your friends? Like, well, there's a bunch of components in there that came from being mined from the ground, like, if not all of the components actually. So it's just like, what do you expect to happen? Okay, let's like think this through. Okay, you stop the production, you stop the mining of these elements, of these components that you need to like create all these things in society. So then where do you go from there? Like, just like, what is the solution?
Well,
like,
and that's just it, right? Like, I don't know what this guy would say if we asked him what he thinks the solution is, but it's like, if I made the assumption that he's advocating for a pause on technological advancement, a pause on just what we production, and changing all of our types of lifestyle, that's a whole different kind of ballpark. Like, I kind of can understand where those guys come from, but at the same time, it's so separate from the trajectory we're currently on that
from reality.
It's it starts to border on delusion. Yeah. So
yeah, it's just like, come on, man. Like, grow up, bro. You're like 12 or some shit. Come on, man.
But
I just don't think that we should destroy the planet in order to save it. Okay. Calm down.
The quote honestly remind me of that movie, Planet of the Humans, and some of the things that were said in the conclusion there. We finally have to face the fact that it's, not the CO2 molecule, but us destroying the planet.
It's not the CO2 molecule, but the human molecule. Dun, dun, dun.
We are the plague on the planet. We are the plague.
Show yourselves.
And this is not to say,
kidding,
all jokes. Kidding. Yeah, obviously, the joking here, but I absolutely love conservation efforts, and there's a time and place to like maintain the diversity on this planet and maintain beautiful areas that we can appreciate in nature. There should be a very thorough analysis done when you consider where you're going to start mining and making the selection that has the right cost and benefits. And, frankly, I don't know enough about the selection of this site to say whether or not I would agree with the placement of a mine here. It's hard to say. These are things that have to be done. Analysis has to be done for this. But, mining is a reality. That's, I guess, the final point. The mining is a reality. It happens. And like we said, there's better ways to do it. And if we do it in the countries that are wealthy enough to consider environmental impacts and consider the rights of workers, I think we're choosing a better way of mining.
I think it's time, like we've exported these productions to other countries because it's been convenient. Like, we're exporting the waste, but there's so many benefits where there's jobs, not only the jobs that can be created economically, but then also like the emissions can be dealt with more strategically than if we were to rely on like China to do it. Like, I'm sure they're doing some stuff, but not everything. Again, and not to the same standard. But yeah, anyways.
Right. So I think we've talked a lot now about how lithium is extracted, the environmental impact of it. Now, what I want to do is close off on talking about recycling. And when I looked into recycling, I came across this company called Li-Cycle. Li being the periodic short form for lithium on the periodic table. It also seems like you're talking about life cycle, clever name for a company. And they're a Canadian company, and they are a leader in North America in terms of developing a technology that can economically recycle lithium. And this is so important because under current economic conditions, if you can't make it economical, you're not going to have recycling happen. Okay? You're going to have this one-way trajectory of extracting a resource from our planet, a finite resource, and it being disposed of in a way that just puts that resource back into the ground and combined with all the other parts that we've put into it. So when you create a battery, it doesn't have lithium, it has cobalt, it has nickel, it has plastic, it has other metals in it. So recycling is huge. And what I did was kind of go through some interviews that different outfits did with the chief commercial officer at Li-Cycle. I might be butchering his name, but I think it's Kunnel Felfer. And he basically sits down and talks about how the life cycle process works and what they're able to achieve. And now it says on their website that they're able to achieve an unparalleled recovery rate of up to 95% of all materials. So I read that as probably from some materials, and they don't specify which ones they are, it's going to be lower than 95%. 95 is very good for recycling something economically, because if you're trying to get to 100%, it takes way too much energy to do that. That's why a lot of places don't do it. And the components of a battery vary, like I've said earlier. So lithium is just one part of it. So why don't we jump into that first clip of the life cycle interviews.
But what are some of those common myths that come up around lithium-ion battery recycling?
Yeah, I mean, one of the interesting things when the business was started was that the lithium couldn't be recovered actually from lithium-ion batteries, and that's what, from a technology perspective, we've sought to resolve and get rid of that notion that you can't recover the lithium back from the lithium-ion batteries in an economic manner, I should say. But I think the other thing is that there are other parts of the process, and existing companies often would, discharge in very rudimentary methods of discharging and then dismantling the batteries. And these are problems that we've overcome, and Alan can speak to this too, but when we go out to the market and meet with new customers, people can't believe that we're able to shred batteries in a submerged fashion safely without any thermal event or fire associated with it. So linked to what Alan was saying, I mean, safety is a big part of it, and that's why people have maybe hesitated or shied away from recycling these batteries. You can simply just shred alkaline batteries. There's no or very little risk, but you can't just take a shredder and shred lithium-ion batteries. It'll cause a fire, and that's linked to the myth. It was that, can you do it safely and still have a high recovery rate? And that's one of the things that Li-Cycles aim to resolve.
So I thought that was fascinating. I had no idea how people would even go about recycling a lithium-ion battery, but the concept is battery recycling begins with basically the shredding of the battery. There's a little bit of sorting that happens, like between small batteries and big batteries, but the first step in this process is shredding them. And the thing with lithium, as this CCO points out, is you put it into a shredder, it goes boom, it catches on fire. There's a high risk that I think you called it a thermal event occurs. And so what they're doing at Li-Cycle is actually doing the shredding underwater or in solution to reduce this. And this, I think, was the key concept that allowed them to get into lithium recycling But it was interesting to hear him say that, like, at the beginning of the company, they didn't even know how to recover the lithium part of the lithium battery. They were probably recovering other parts of it, like the plastics and other metals, but they were able to actually capture a significant amount of the lithium. Because if you have another thing, I'm thinking happens if you allow a fire to take place in your lithium battery, you're basically starting to burn shit. Right, you're burning the components of it.
Yeah, exactly.
And you're destroying
product.
Yeah, you're losing some of that material.
And I think that's so powerful that they've actually started to recycle lithium batteries, because I think that has been one of the limiting factors of the batteries, that like once we're done using them, what do we do with them? Do you just dig them in the ground or whatever? But if we can recycle them in a sustainable manner, then that's huge. And I think with the kind of like the first generation of EVs of Tesla is kind of coming to their life cycle like ends, and like a lot of those batteries kind of being used, and then now later being used for like energy storage, then they're probably we're gonna see an influx of demand for like, okay, all these spent batteries that need to be taken care of, they need to be recycled somehow. So it's like the perfect timing almost.
Yeah,
it seems.
And that's what he actually gets into that a little bit in his interviews, just talking about like this is such a pivotal point in their company as there is more push to create EVs. There's the aging EVs are from 6-7 years ago are, some of these batteries are going out for waste, and they're seeing just demand for recycling, and really anybody that's critical of these companies like Tesla and saying, are you actually environmentally friendly? What are you doing with your lithium at the end? They're looking out and saying, what can we do? And who's providing us recycling options? And that's why I think Li-Cycle is becoming, or is the number one recycler in North America.
Yeah. Definitely.
So a few more of these clips to just talk a bit more about the process that they're applying here.
The limiting factor for EV production is the amount of batteries that can be produced. How do you re-ingest a battery back into the system once that it's gone through the life cycle?
Yeah, for sure. So what we do is when we take the batteries, we're bringing it down to the fundamental building blocks. So cobalt chemical, lithium chemical, nickel, and our relationships on that end, and we're starting to develop those as we increase our volume, is to bring that back into one step before the cell manufacturing, so the cathode manufacturer, right. Because they're the ones that are taking those pure or those individual materials and creating a product that goes into the cell. Those relationships can be strengthened through partnership with the cell manufacturer as well, but that's where we reinsert ourselves into the supply chain.
So one of the things I've always wondered about lithium recycling is it downcycled? And what I mean by that, is it that after they do their whole process of trying to extract the materials from the old battery, is that used to make an inferior product? And what I've found so far is it's not the case. They've actually been able to reproduce these materials to a level that they can be used to make the same product again, which is fantastic. That is what recycling needs to be. It needs to be, things need to be, not downcycled, but upcycled, or at least be able to make the equivalent process.
That's powerful.
Yeah. So I got one more clip from him, and sorry.
No.
Yeah. Well, I'll just say one more clip from him, and that kind of rounds off the whole recycling bit of this.
Let's do it.
You have a technology hub and spoke and hub. Explain how that works.
Yeah. So when the company was founded, we really saw that there's a few key challenges. One of them being the centralized nature of sort of legacy technologies. And one of the industry challenges is less so on the small format, but still an issue. But on the large format batteries, these things are heavy, and basically your cost to move them to a recycler is based on the weight and distance, right? So what we've done is decoupled the two-stage process with the spoke and hub concept, so that the spokes can be a decentralized first stage process. And what that does, simply put, is shred the battery into inert products. Some of it is just plastic or copper aluminum that can be recycled more locally. And then the high value material enters in an intermediate product called black mass that we can ship to a centralized hub, which then refines it into those core materials like cobalt, nickel, lithium. And that process benefits from scale and being in a centralized approach to get the economics to work in a positive manner. So that's how we've split up. And that second process is a chemical process, a hydrometallurgy process that processes that black mass.
Okay, I found this fascinating. So he's basically talking about how have they made the economics work for this recycling process. So they came up with this term spoke and hub, and hubs are centralized recycling plants that deal with the black mass, and spokes are kind of like these mobile facilities that you can bring out to wherever you have your lithium waste. And the spokes would be just facilities that are set up to shred the lithium battery and produce, separate the, what do you say? I think it's copper and plastic, which you can then recycle locally in whatever municipality or town you're in. And then it also produces a black mass that is a powder that are put in these large 1-ton bags and shipped off to the hubs to get refined into pure versions of lithium, cobalt, nickel. Mm-hmm. But it's just, he's just talking about, realistically, to if you just had hubs and you were trying to ship all the heavy lithium batteries to it, those shipping costs are going to basically make the process uneconomical or less economical. So it
makes sense. Yeah,
it does make a lot of sense, and this is one of those clever ways, that solution. We have so many solutions that are available to us, but the other thing we have to contend with is the economic system. So just because we can do something, we often can't do it because there's just no positive economics on it. And so when I hear about a company achieving both a good solution and they're able to make money off it, kudos to those guys for doing this. Yeah.
I think like when it comes to like the efficacy of a process, again, like we need to look at kind of like what we said at the beginning, like the cradle to grave analysis, and these guys have really addressed that grave aspect of like what do we do to bring these bad boys back to life. So once they've like served their life as the battery for an electric vehicle, for some sort of energy storage, and then like what do we do? Well, these guys come in and they are able to like grind it up, separate it through their chemical process, and go back into the supply chain. And I think that's powerful, and makes it helps further the case of lithium, so that when environmental groups do complain about it, at least there are things that can be done, because again, we have to take like a realistic approach of what of like how these things are managed, and like there is waste. So okay, if this is true, then we have to also know like how do we handle this waste. So one other way when it comes to handling the waste actually is when it comes to the rare earth metals that are within these vehicles. Something that I came across which was interesting was that a lot of companies were looking at changing their what's it called, their methodology, so that way they weren't using these rare earth metals, because as I said, the neodymium supply is heavily controlled by China, and separating the materials requires huge amounts of carcinogenic compounds like sulfate, ammonia, hydrochloric acid. So it's a pretty dirty process in its own right. And processing 1 ton of this rare earth produces 2,000 tons of toxic waste. right? So one ton of processed metal leads to 2,000 tons of toxic waste. So it's pretty dirty stuff. And again, we're relying on China for it, and a lot of companies such as BMW and Renault have looked at creating or moving away from the supply from China and creating motors that don't rely on these metals. So I think it's kind of like an interesting way of just like, again, like ingenuity, kind of like being creative, and how, like, for example, it says here, Renault has utilized a wound rotor configuration to replace magnets with copper windings. So the neodymium is used as a magnet, and it's a really efficient magnet, right? So what these guys have done is they're winding a router configuration with copper windings, and BMW's 5th generation drivetrain has eliminated the rare earths, and Audi has opted for an aluminum rotor induction motor for the e-tron. So it's just to say that, there's a lot of like ingenuity, and there's a lot of I think a lot of companies are recognizing the threat or the potential for a threat when we are heavily reliant on one source for these rare earth metals. And there's it's kind of cool to see that they're responding by creating these alternative motor configurations, or just different ways of doing things as a result. So that way we're not even using the metals at all.
That's huge.
Although, with that being said, with the I found this other article from Forbes that says that, funny enough, so even though there's some good news in that side, the U.S. still needs 10 times more rare earth metals to hit Joe Biden's electric vehicle goals. So because the U.S. has pledged to increase its electric vehicle production and subsidize this and that, it inevitably means that we're going to need 10 times more of these rare earth metals, perhaps, unless we really jack up the production of these alternatives that don't use these rare earth metals. But it kind of
again, it goes
a huge pressure.
And is that going to happen in parallel with the attempts to meet this goal? Mm-hmm. Something that we didn't touch on, but I think is key in all of this, is going back to why are we trying to go to these electric grids and to these electric vehicles? Well, we're being told we're trying to go to them to reduce CO2, right? So when we are trying to import thousands of tons of rare earth metals from other places, we require shipping. Shipping happens all the time around the world. But the important thing that people need to realize is shipping comes with a carbon footprint. So the more you have to ship stuff, the more you're creating this carbon footprint. Emissions. And from further distances is a larger footprint. And so,
arguably, that's where hydrogen vehicles would come in, hydrogen engines. But
exactly. Point. Would be a one way of solving that issue. Okay, yes, we have to transport things for long distances because we can't get a local solution, or we can't substitute some other material for it. So yes, we're going to have to use these mines that are located in certain locations across the world. So we're going to rely on shipping, but the shipments are going to be done with a low CO2 fuel source, such as helium. So, but that's, again, I just don't want people to get this idea in their head that somehow we're eliminating CO2 when really we're just creating it from where CO2 emissions are coming from are just moving to different areas. And we got to be really careful.
We're managing the point sources.
100%. So whenever you see an analysis done about, this is this much better for CO2 reasons, you really have to get into the weeds of what was considered. Are they considering these externalities? And often we are not. We haven't been doing it for a long time, and we've talked about externalities in our podcast on carbon tax. And if we're really thinking we need to reduce CO2, you have to start considering this bigger picture of everything. So,
and what's the time frame of analysis that you're looking at, right?
Another thing, right? These things don't have an immediate benefit. In fact, the benefit's going to take a few years. If we make products that last a few years, that's okay. But if these products start to break down before they break even, then what is the point?
Yeah.
You know?
Exactly. Again, like 125K until you break even. Frig, that's like 65. Like, come on, man. Like, but like to me, that like coming up with that number, that was so mind-boggling. Honestly, like just the fact that like the push is coming towards electric vehicles, but meanwhile, you're not going to see that payback period for at least another 8 years. And the catastrophe is going to happen by then. So
the alleged catastrophe, yes, exactly.
So the solutions that are being proposed are just like, I guess maybe that would further incentivize them to say that they're not radical enough. And some people are like, oh, we got to go even more radical. Some people might take the wrong lesson from that, but anyways,
yeah.
There's always another reason to go more extreme, I guess.
Yeah.
But yeah, that company, I was trying to actually like look into what they did.
Which company is this?
Turntide Technologies. They're a U.S. startup that makes energy efficient electric motors without rare earth metals, and they raised $225 million, underlying growing investor appetite for a climate technology startup. So I tried to go into, and this was an article from June 30th, 2021, so pretty recent, but I couldn't really get into the details of how their technology actually worked. But it's, I don't know, some breakthrough stuff that's going to accelerate electrification and sustainable operation for energy intensive industries, just reading off their website there. But yeah, no, again, I guess it's cool that there's innovation happening and people are moving away from these magnet-based motors towards, I guess these are air-based or something, like, yeah, I don't even know. That could be a subject of discussion for another episode, but anyways.
Yeah, it definitely could be, and there's so much innovation happening, and at this moment in time, because of this push to make electric vehicles become the dominant form for transportation, especially for like passenger vehicles and such. But and we're a lot of companies keep this stuff hush hush until they have a product they can put out there, and then we just get a chance to talk about and look at their actual products once that happens. So there's definitely more to come on this, and I did want to clarify my point, saying what I said earlier, like what's the point? What's the point is not me saying don't buy an EV. The EVs still have a chance of being the better option. My point is we need to be careful here, because there's other things that have to fall into place for them to be actually the better option, and so it's not me saying don't, if you're into the whole EV thing, stick with it. I think the innovations are happening and we're going the right way, but it's not the silver bullet that is being sometimes said that it is. Yeah.
That part is true from what that kid was saying, is that it is not a silver bullet, and hopefully it's one technology of many, but as you said, it's kind of like there's a bunch of other things that have to be happening in conjunction, in parallel to the electric vehicles, whether it's the recycling and the reintegration and the upcycling or whatever, and just getting like that diverse, or maybe even moving away from them entirely. So yeah, I think there's many different things that have to be happening. And I don't know, any last thoughts on this episode before we wrap up there?
Just wanted to say this is what we kind of do on this podcast. We talk, we get into the nitty-gritty details about different environmental, sustainable, green technologies and try to really, break them down. Really look at what they are going to achieve realistically. And if you enjoy this, I hope you consider supporting us in the future. We're working on that still, and that's why I just want to remind people that when you come to this podcast and you hear us bring up these issues, this is not something you're going to hear on other places. There's a lot of channels out there where all these technologies are being discussed. I want to say almost superficially in some ways, and what we're here to do is discuss some of the problems with them, not just to shit on them, but to make people aware that these are real problems and that there's more that needs to be done when it comes to these different technologies.
Mm-hmm. That's a great point. And if you like this episode, there's another episode that we did that talked about hydrogen and the integration of hydrogen into the economy and how it and what role it plays in the conversation of a sustainable energy grid. So if you like this conversation, then you like that one, head on over to our Apple Podcast, Spotify, our website. You will find the library of all our episodes. Hydrogen is one of our most recent episodes. If you liked it, give us a 5-star review. Tell your friends. Please give it a share, and we will be catching you on the next episode. And this is Trees. I'm joined by my co-host Elliot, and we'll catch you guys next time. Break down from the ground up. First Principles signing out. Peace.
Peace.